In 2026, the scientific community finds itself once again turning back to a theory proposed over a century ago, one that continues to withstand the most extreme tests of nature and the most advanced technologies humanity has ever built. Albert Einstein, a name that has become synonymous with genius, revolutionized physics with his theory of general relativity in 1915. At a time when the world still viewed gravity as a simple force acting between objects, Einstein dared to propose something radically different, that gravity is not a force at all, but a curvature of spacetime caused by mass and energy. This idea, elegant yet profoundly complex, reshaped our understanding of the universe. And now, more than 100 years later, a new discovery has once again confirmed that Einstein was right, leaving scientists both amazed and inspired. The latest breakthrough comes from the detection of powerful gravitational waves, ripples in the very fabric of spacetime. These waves are generated by some of the most violent events in the universe, such as the collision of black holes or neutron stars. Imagine two massive black holes, each containing the mass of dozens of suns, spiraling toward each other at incredible speeds. As they draw closer, they distort spacetime more and more, until they finally collide in a cataclysmic event that releases an enormous amount of energy. This energy doesn't travel as light or particles. It moves as waves through spacetime itself. These are gravitational waves, and their existence was first predicted by Einstein in 1916 as a direct consequence of his equations. For decades, gravitational waves remained a theoretical concept, impossible to detect with the technology available at the time. Many scientists even doubted whether they could ever be observed directly. But that changed in 2015 when researchers using the Laser Interferometer Gravitational Wave Observatory, or LIGO, made the first direct detection of these elusive waves. That moment marked the beginning of a new era in astronomy, one in which we could not only see the universe, but also hear it. Since then, multiple detections have been made, each one providing further confirmation of Einstein's theory. However, the discovery made in 2026 stands out as one of the most significant yet. This new detection is being described as one of the clearest and most powerful gravitational wave signals ever recorded. Originating from a collision that occurred approximately 1.3 billion light years away, the event involved two exceptionally massive black holes merging into a single entity. The signal was so strong that it allowed scientists to analyze the event in unprecedented detail. Using advanced detectors and sophisticated algorithms powered by artificial intelligence, researchers were able to reconstruct the entire LIGO from the initial spiral to the final merger. Every aspect of the data matched the predictions made by Einstein's equations with remarkable precision. What makes this discovery particularly shocking to scientists is not just that it confirms Einstein's theory, but that it does so under conditions that push the limits of our understanding of physics. Black hole collisions represent some of the most extreme environments in the universe, where gravity is incredibly strong and spacetime is warped to its limits. If there were any flaws in Einstein's theory, this is where they would likely appear. And yet, even under these extreme conditions, general relativity continues to hold true. This level of accuracy is both astonishing and humbling, reinforcing the idea that Einstein's insights were not only revolutionary, but also deeply connected to the fundamental nature of reality. Beyond the scientific implications, this discovery carries a powerful message about the nature of human curiosity and imagination. Einstein did not have access to modern Arabic Alif Arabic, Lam Arabic, Ta Arabic, Kaf Arabic, Noon Arabic, Waw Arabic, Lam Arabic, Waw Arabic, Jim Arabic, Yet Arabic, Halif, supercomputers, or he Ishal in his observatories. His work was driven by thought experiments, mental explorations that allowed him to visualize complex concepts in simple terms. He imagined how light would behave in a gravitational field, how time would slow down near massive objects, and how spacetime itself could bend and ripple. These ideas, once considered abstract and even speculative, are now being confirmed through direct observation. It is a testament to the power of the human mind and the importance of thinking beyond conventional boundaries. The role of artificial intelligence in this discovery also highlights how far science has progressed. Modern detectors generate enormous amounts of data, far more than humans can analyze manually. AI systems are used to sift through this data, identify potential signals, and distinguish them from background noise. In the case of gravitational waves, these signals are incredibly faint by the time they reach Earth, making detection a significant challenge. AI not only speeds up the process, but also increases accuracy, allowing scientists to detect events that might otherwise go unnoticed. This collaboration between human insight and machine intelligence represents a new frontier in scientific research. Gravitational waves themselves are transforming our understanding of the universe. Traditional astronomy relies on electromagnetic radiation, visible light, radio waves, X-rays, to observe celestial objects. However, many cosmic events do not emit light in ways that can be easily detected. Black hole mergers, for example, are often invisible through traditional means. Gravitational waves provide a completely new way of observing these events, offering insights into phenomena that were previously hidden. This has given rise to an entirely new field known as gravitational wave astronomy, which is rapidly expanding our knowledge of the cosmos. As more detections are made, scientists hope to uncover new information about the formation of black holes, the behavior of neutron stars, and even the origins of the universe itself. There is also the possibility that future observations could reveal deviations from Einstein's theory, pointing toward new physics beyond general relativity. But for now, the continued success of Einstein's equations in describing the universe remains one of the most remarkable achievements in the history of science. For viewers and learners, this story is more than just a scientific breakthrough. It is a source of inspiration. It shows that great ideas can transcend time, that imagination can lead to discovery, and that persistence can turn theory into reality. Einstein's journey reminds us that innovation often begins with a simple question: what if? What if gravity is not a force, but a curvature of spacetime? What if we could detect ripples in the universe itself? These questions, once considered speculative, have led to some of the most important discoveries of our time. In a rapidly changing world, where new technologies and ideas emerge every day, the story of Einstein and gravitational waves serves as a powerful reminder of the importance of curiosity and critical thinking. It encourages us to look beyond the surface, to question assumptions, and to explore the unknown. Whether you are a student, a scientist, or simply someone fascinated by the universe, there is something to learn from this discovery. It is a reminder that knowledge is not static, but constantly evolving, and that each new discovery brings us one step closer to understanding the universe we live in. As we move forward into the future, one thing is certain: the legacy of Einstein will continue to influence and inspire generations to come. His theories will be tested, refined, and expanded, but their core insights will remain a foundation of modern physics. And as scientists continue to explore the cosmos, using ever more advanced tools and techniques, they will undoubtedly uncover new mysteries that may once again lead them back to the ideas of a man who dared to think differently. Einstein was right. And in 2026, the universe has proven it once again. Rocket